Okay, I want you to notice the title of this lesson, Rewriting Absolute Value as Piecewise Functions. Now, this is something you have never done before, but the first part you're going to say, oh, this is really easy. Now, so the first thing we're going to look at is how to write that as a piecewise function. Now, you're probably saying, well, wait a minute, that's its own function. Why would I write a piecewise? You know how an absolute value looks like that? Well, if we consider there being a fence right there, this function is linear on this side, so we could write a y equals mx plus b. The function is also linear on this side, so we could also write another y equals mx plus b. That's breaking an absolute value function into a piecewise. We're going to write it as two linear functions. Now, that part's real easy. I actually learned something really new when I first taught this last year. I had never seen this before. If you look at the top of the next page, you're going to write this as a piecewise function. When I first saw that, I thought, I have absolutely no idea how to do that. And I didn't know how. But I walked through the author's work and it's like, okay, I think that's just about the coolest thing I've seen. And it works just really nice. So you're really going to learn something new here that I think you'll think is pretty cool. Okay, let's go back to Algebra 2. Many of you graphed absolute value functions in Algebra 2, and you know that they're always a V, right? Right. Now, I want you to look at this one. Can you tell what kind of transformations happen in that from the regular parent function? What happens? Where do you get that 2? Where's that 2 come from? Good. Now, here's my question to you. Why don't you take a look at that? Take a look at that. I don't have enough room. The absolute value of 2 times 3. Is that the same as the absolute value of 2 times the absolute value of 3? You shouldn't have to guess. It is. They're the same thing. What if I made the 2 negative? Negative 6. The absolute value of negative 6 is 6. 2 times 3 is 6. If I make them both negative, are they the same thing? They're still the same thing. Now, if I give you this, then that should be the same as, you buy that? Those are the same as well. But that means this is 2 times the absolute value of x plus 2. Yes, no, maybe. Got it? Okay. This is what we're going to do with what Tristan just said. So we're going to think, okay, this is equal to the absolute value of 2 times x plus 2 minus 3, which gives us the absolute value of 2 times the absolute value of x plus 2 minus 3. So you ought to be able to tell from there, not only do you have a left 2 and a down 3, what does this lead to do? Which way? Stretch which way? Vertical stretch by a factor of 2. Good. Now, when you had the parent graph, when you were just looking at this, you know it looks like this. What are the slopes on either side of that vertex? What's the slope on the right side of the vertex? 1. What's the slope on the left side of the vertex? -1. So what are the slopes going to be on either side of our vertex in this graph? 2 and -2. So what I want you to do over here in the grid, we're going to graph that thing. So we're going left 2 and down 3. Does this V open up or down? And don't say it opens up because I got more room up than down on the grid. Does it open up or down? How do you know that? Good. The leading coefficient is positive. So we're going to open up. We're going up to right 1 on the right side. We're going up to left 1 on the left side. Oops, what did I miss? Good so far? I don't know, are you doing the right thing? Now, what we're going to do is we're going to break this into 2 parts. We're going to break it at the vertex. So we're going to break this thing right here. And I'm going to say I've got 1 line in that left yard and 1 line in the right yard. What are the constraints for this dude right here? What yard does he live in? Yep. And we're just going to put x is less than -2. What about the other guy? X is greater than -2. Great question. Who owns the fence? Can you tell? Can you tell if one was an open circle and one was a closed circle? The open or the closed circle filled in the open circle, right? So it's either one. You pick. Doesn't matter. One of them. Now there will be some books, some mathematicians say you can let them both own it. I got a problem with that. We're going to let one of them own the fence. Does it matter? No. Pick one. Sir.
How come on the correct? Oh yeah. You put the line down.
This author, in his notes, he lets both of them own the fence. I have a problem with that. I just let one of them own the fence. There are some mathematicians, though, who let them both. So I would not count either way wrong. Now what we're going to do is we're going to actually write the equation of the line for the piece that lives in the yard x is less than -2. Well, remember the equation of a line is this. So what's the dang slope? -2. What's the y-intercept? No. If I took this line right here, kept sloping that -2 and ran it into the y-axis, -7, because you'd go right 1 down 2, right 1 down 2, I'd end up on -7. -2x minus 7. What would the equation for this piece be? 2x. Now don't go according to mine because I'm off. It is 2x plus 1 though, isn't it? Guys, that's what it means to write a piecewise function. That's what it means to write an absolute value function as a piecewise function. This is a skill you will need just a time or two in calculus, okay? Now, the author has given you these steps. And you're like, well, why do I need steps? I already know how to do it. You do know how to do it on this problem. You don't know how to do it on this one. So we're going to learn the steps on an easy problem so that when you get to that, you'll know what to do. Okay? Here we go. I'm going to erase all this nonsense. No, it's not nonsense. I'm going to erase all this stuff so I have some room to do stuff. All right. I shouldn't have erased the graph, dummy. Okay, well, all right. Follow the strategy outlined below. We're going to set each expression inside any absolute value bars equal to 0. What do you see inside absolute value bars? 2x plus 4. So you're going to write 2x plus 4, you're going to set it equal to 0, and you're going to solve for x. What do you get? -2, ladies and gentlemen. Do you remember we had a shift left 2, didn't we? That shift left 2 comes from right here, -2. Now, step 2, draw a number line. Closer to the top of this box than the bottom, but not right at the top. I want you to draw yourself a number line. And we're going to put whatever value we found right here, we're going to put that on the number line. I'm right here. I'm right here. Write the entire equation of the function in each interval, replacing the absolute value bars with parentheses. So here's what I'm going to do. Notice that that -2 breaks the number line into two parts, less than -2 and greater than -2. I'm going to rewrite this equation below, but I'm just going to replace the absolute value bars with parentheses. So I want you to write it like this. Now let's go to step 3, but I'm going to do the work on step 3 on the box on step 2. Determine the sign of each expression in parentheses by choosing a value from each interval and substituting in for x. Place the sign in front of the expression on each interval. That's a whole lot of hoo-ha to say to do this. Pick a number less than -2. Fine. Now, does -3 make what's in the parentheses positive or negative? 2 times -3 is? -6 plus 4 is? It's negative, right? Stick a negative right outside those parentheses. And what we're going to do in a minute is we're going to distribute a -1. Now we're going to do the same thing on the other side of x equal -2. Pick a number bigger than -2. -1, fine. I always pick 0, but if x is -1, is 2x plus 4 positive or negative? Right. Stick a little plus right there. I'm going to distribute a +1. You're saying, well, why do you do that? You keep the same thing anyway. Yeah, you do. But sticking the plus out there reminds you that you've done it. Now we're going to step 4. Simplify the equations on each interval by distributing the signs you just figured. All right, so fine. Here, distribute the -1. I'm going to have -2x minus 4 minus your 3 is -2x minus 7. Dun, da, da, da. Dun, da, da, da. Right there. We're going to distribute a +1, which means that's just still 2x plus 4 minus your 3. 2x plus 1. So when x is bigger than -2, your equation is 2x plus 1. Dun, da, da, da. It's pretty slick. Pretty slick. Now let's try it on this bad boy. It's not any harder. All right. Set each expression inside the absolute value equal to 0 and solve for x. What's inside the absolute values? X plus 4 and x minus 1. Solve for x. Those are the two numbers you're going to put on your number line. So step 2 is draw your number line. Now, I'm going to make one comment, and you may think, okay, I'm not stupid. I know you're not. But somebody is going to do this. What's the problem? -4 is less than 1, so you got to put the -4 first. Somebody's going to do that and then they're going to get all messed up and go, what? Now, I'm going to write my equation in each of those sections. But how many sections do I have now? I got 3. So I'm going to write that equation 3 times, replacing the absolute value with parentheses. So, you all right, Nick? X plus 4 plus x minus 1. It's all right. X plus 4 plus x minus 1. X plus 4 plus x minus 1. Now I'm going to pick a number in each of those intervals and see if it makes the stuff in each set of parentheses positive or negative. Pick a number less than -4. -5. Does -5 make this first set of parentheses, x plus 4, positive or negative? Negative. Stick a negative right there. What about x minus 1? Negative. We'll distribute negative ones in just a little bit. Pick a number between -4 and 1. Hey, 0. Does 0 make this first parentheses positive or negative? Second. Good. Last interval. Great. Positive or negative? And great. Now let's clean them up. On this purple one, I'm going to distribute a -1. So I'm going to have negative x minus 4 minus x plus 1, which gives me what? Negative 2x minus 3, is that right? The middle one, I'm going to distribute a positive 1 on the first set of parentheses and a -1 on the second set. So that's going to give me x plus 4 minus x plus 1. What's that give me? Just 5, isn't it? See, there it did it again. I don't know. Last set, I'm going to distribute a positive 1 to both sets of parentheses. X plus 4 plus x minus 1. It's going to give me 2x plus 3. Now all I have to do is write my piecewise function. So I'm just going to write it right here. I don't remember if that was f of x. It doesn't matter. That's just irrelevant. Spelling error. The function is negative 2x minus 3 when? When x is less than -4. This function is equal to 5 when? Good. So we're going to say between -4 and 1. And this function is 2x plus 3. I don't know. When x is bigger than 1. Now what's the only thing we haven't done? Who's going to own the fence? How many fences do we need? 2. You need to let somebody own the fence at x equal -4. So it's going to be one of these. I don't care. It doesn't matter. And somebody needs to own the fence at x equal 1. It doesn't matter. I'm just going to let this dude own both fences. And ladies and gentlemen, that's how you write an absolute value as piecewise. That's it. That's pretty cool, isn't it? Now, let's graph it. Let's graph it. You know how to graph a piecewise. -4 and 1. Because I want you to see what that graph looks like. And here's what I guarantee you. You'd have had trouble graphing that function as is. If you had tried to graph that function without changing it to piecewise and not knowing how to do that on a calculator, you'd just been SOL, wouldn't you? You just wouldn't know what to do. So, okay. When x is less than -4, -2x minus 3. Okay, let's find it. Which yard does that -2x minus 3 live in? Left yard, middle yard, or right yard? Left yard. Y-intercept's -3. Is that in his yard? No, keep sloping -2. Up 2, right 1. Not in his yard. Up 2, right 1. Up 2, right 1. Up 2, right 1. Now, oh, I need to change my color. Up 2, right 1. Up 2, right 1. I said right and went left, didn't I? I did it right, I just said it wrong. Yes, thank you. Now, you may be thinking, well, why'd you put in a filled-in circle? Because he didn't own fence. Every is going to connect either way. Yeah. Y equals 5 in the middle yard. Two x plus 3 in the right yard. Y-intercept's 3. Up 2, right 1. Up 2, right 1. Up 2, right 1. There's the rest of it. We don't ask. We don't ask. What's your domain? Domain's all reals. What's your range? 5 to infinity. Good. Good. 5 to infinity. Domain is all reals. All right, giggle boxes. Questions here? Y-intercept. On this piece here, the y-intercept's -3, but that's not in the right yard. So that's why I just didn't make any points there. It would have been down here. And if I go up 2, right 1, I'd have landed here. Up 2, left 1. Up 2, left 1, up 2, left 1, up 2, left 1, up 2, and I would have ended up right there. Bam, right there. Okay. Okay, look at your last page.
I think I haven't gotten to this part when doing this, but is that right?
Here we go. I think this one may be the last one we do right here. Notice the rules are not listed there. Those steps, that's fine because we don't need the steps anyway. We just got them up here. We got them right here. What's your first step? Set what equal to 0? Good. What's inside the absolute value bars? Guys, listen, you don't have to write that line down. You ought to be able to look at that and say, oh, my issues are going to be at x equal -2 and x equal 3/2. You don't have to write that first line down. What do I do now? Draw your number line. I'm glad graphing is so funny. It's all right. It's all right. Believe me, I get you. I get you. You're just mental. All right, Brooklyn's mental, so. What's new? What do I do now? Yeah. Now, I just don't have room. You do because you have a pencil and you write smaller. I'm going to have to write it like this. X plus 2, that's x plus 2x minus 3. Because that's how you solve a thingy-ma-bobber-doodle? Yeah. Huh? All right. What now? Good. We're going to find a point in each interval and plug it in. Less than -2? Fine, -3. And we're going to decide, does -3 make each of those sets of parentheses positive or negative? First, makes it negative. Second, negative. Pick a number between -2 and 3/2. Great. Positive or negative? And? Good. Last? 2, fine. Good. Okay, where'd the woe come from? Okay. Oh, yeah. Clean them up. Question? Oh. Y'all are such math nerds. I love it. Okay, clean them up. -x minus 2 minus 2x plus 3. Did y'all get -3x plus 1? Did you get -x plus 1? Dummy. Thank you. -x plus 5. Is that better? Yeah, okay, yeah. Mercy. Three x minus 1? Okay. I'm just going to go right down here because I don't have room. So we got -3x plus 1. We got -x plus 5. And we got 3x minus 1. Yes, it's okay if you're terrible at the squiggle thing. It's called a brace. You've got brace, bracket, parentheses. What are your, here we go. What are your constraints on -3x plus 1? Less than -2. The constraints on the middle piece. And then the last one. What's the piece we still need to do? Yep. Who owns the fence? Graph it. There you go. You're not going to miss that part, are you? Now listen. Can I safely assume you can graph that okay? Don't assume. Don't assume. Assuming is a bad idea. All right, so I won't assume. Okay. Let's graph it then. I could assume, but I'd be wrong. Okay. All right. Now I know how it is. Yeah, start graphing. I got, oh, crap, I don't want to paste. What do I want to paste? All right, -3. Okay, I got to get my yards, my fences in. -2 and 3/2. Negative 3x plus 1. 2, 3, 1. 1, 2, 3, 1. 1, 2. 1, 2, 3, 1. 1, 2, 3, 1. And remember, it doesn't matter if you go ahead and fill in that circle, they're going to connect anyway. Negative x plus 5. Eh? What? I started at 1, but that was in the wrong yard. So I just started sloping up 3 left 1, up 3 left 1 until I got onto the fence. Did I do it right?
Yeah.
I didn't do that right. I didn't count right. Golly bum. 1, 2, 3, 1, 1, 2, 3. I was right. What's the matter with me? What's the matter with me? 7. I think I'm getting part-timers. I don't know. Alzheimer's. Instead of Alzheimer's, part-timers. Negative x plus 5. I can do that part. 5. Now, you're thinking, but if I go right 1, down 1, I'm going to cross the fence. Just run that thing into the fence and stop there.
Excuse me, teachers, not had a chance to read the email that I sent out about 20 minutes ago, but check that real quick,
All right.
get some information.
All right. I guess I got to go check it. Okay, listen, 3x minus 1, so there's minus 1, 1, 2, 3, 1, 1, 2, 3, 1. So just do that, 1, 2, 3, 1. Now remember, an absolute value function, go, what the crap are you doing? Move. Sorry, I'm not talking, I can't, he's not moving. He's not moving. Run, I don't know. Is it a bug? I don't know what it is, hon. Listen, just run it into the fence. Just run it into the fence like that. I don't know. What? Hey, start this one. We're not going to do the whole thing, but I want you to start it because there's a little thing I need you to see. Let me go see what Mr. Harden's wanting. What's your significant number here? Negative 4. Sorry? Yeah, yeah. Now look, just get this far with me. If we pick a number less than negative 4, what your issue is because this 2 is already negative, what happens? Now, this negative 5, does that make the parentheses positive or negative? Negative, so I would be putting another negative 1 out here to multiply by. But negative 1 times this negative 2, so just make that a positive 2 to distribute. If I pick a number bigger than negative 4, good. 0 plus 4 is positive, so I would be putting a positive 1 out front, but positive 1 times this negative 2 is still negative 2, so that's going to stay negative. And then you do everything else the same way we've been doing. Okay? I'm going to give you your assignment, but I need to talk about one little thing on the back.